Okay, let's get right into it. In the world of artificial intelligence, there's a huge confrontation brewing, a real clash of titans that powers almost everything we see today. So get ready for the big showdown, machine learning versus deep learning. But what is the real engine inside AI? I mean, when you hear that term, what's actually pulling the levers and making the calls? It's a question that really gets to the heart of how our modern world thinks and learns and creates. And the answer? Well, it's really a battle between two absolute giants of technology. You've got the established, seasoned pro on one side, and this powerful, kind of mysterious newcomer on the other. And this isn't just about a technical detail. We're talking about a fundamental difference in philosophy, in power, and in what's actually practical. So first up, let's meet our reigning champion, the seasoned pro of the AI world, machine learning. This is the bedrock, the foundation that so much of modern data science has been built on for years. So what is machine learning at its core? Well, it's the art of using proven, time-tested statistical models to make sense of data. Think about it like this. If you show an ML model thousands of pictures of cats and dogs that are already labeled, it starts to learn the patterns, so it can tell them apart on its own. These are algorithms that have been refined for decades. Their job is to predict and classify, and they do it incredibly well. ML's biggest strengths are its solid grounding in statistics and its long track record, which makes it amazing for prediction. But its killer feature? Transparency. It can actually explain how it came to a decision. If it says a picture is a cat, it can often show you the features it used. The pointy ears, the whiskers. It's the reliable, understandable workhorse. But now, stepping into the ring, here comes the challenger, the powerful newcomer that's been grabbing all the headlines lately. Deep learning. And trust me, it's for a very, very good reason. Now, deep learning is technically a type of machine learning, but it's playing on a totally different field. It's actually inspired by the structure of our own brains, using something called neural networks. Just imagine tons of layers of interconnected digital neurons, where each layer learns to spot more and more complex things, building on what the last layer saw. It's that depth that gives it its name and its power. And this brain-like structure, it gives deep learning actual superpowers. This is the engine behind all those mind-blowing breakthroughs we've seen in computer vision and speech recognition. It's the magic behind generative AI, the stuff that creates art, music, and text that sounds shockingly human. What it can do is a total game changer. But here's the catch. This world-changing power comes with a great big mystery, a fundamental trade-off that puts it in direct conflict with its older sibling. And that brings us to the main event. It's time to put these two titans head-to-head and see where they really shine and where they fall short. This is the showdown that developers and data scientists are facing every single day. Round 1, explainability. With machine learning, you pretty much get clear, traceable logic. You can follow the breadcrumbs. But with deep learning, you get what everyone calls the black box. And this is the core dilemma. The black box means that a lot of the time, even the people who created a deep learning model can't fully explain why it made a specific decision. The answer it spits out might be incredibly accurate, but the reasoning is buried deep inside millions of tiny calculations across all those layers. It's almost impossible to trace the logic from point A to point B. Round 2, data needs. Machine learning can do a lot with smaller, well-organized sets of data. But deep learning, it is famously data hungry. To pull off those amazing results, you have to feed it a colossal amount of information. That's because it's basically learning everything from scratch, with very little human handholding. And round 3 is a big one, ethical risk. Because machine learning is more transparent, it's generally easier to spot and fix biases. But with deep learning's black box, a hidden bias could be making decisions, and you might never know why. That makes the potential for misuse, even accidentally, a whole lot higher. So let's just lay out the trade-offs. Machine learning, the pro, gives you high accuracy and, this is key, high explainability. It needs less data, which is a huge plus. On the other side, deep learning, the challenger, can hit levels of accuracy that are just off the charts. But it's a data-hungry black box, and that comes with a higher ethical risk. Okay, so let's get to the final round. How do you actually make a choice? How do you pick your champion when the stakes are this high? And the honest truth is, there isn't a single winner. There's no one champion. The real winner is the person who knows which tool to pull out of the toolbox for the right job.
It's not about which one's better, it's about which one is the right strategic move for the problem you're trying to solve.
So, how do you choose? First, you gotta assess the stakes. Is getting the absolute most accurate answer more important than being able to explain how you got it? Next, check your resources. Do you actually have the mountains of data that deep learning needs to even get going? Then, think about the ethics. Seriously, what are the risks of letting a black box make a critical decision? And finally, just focus on the real value. Don't get caught up in the hype. Pick the tool that actually solves your problem. And that leaves us with one final, really crucial question. As these incredible AI tools get more and more powerful, we are going to face this choice again and again, in situations with higher and higher stakes. So what will we prioritize? Will we choose the tool that we can actually understand and control, or will we just end up choosing the one that wins?